Okay, so welcome back. This is part 2 in our series where we show you how to develop this application, which is a data logger, a real-time data logger. And we're going to use C# for this application, but you can use whatever software you want. The concepts here are pretty much straightforward. And I also encourage you to look at part 1 where we talk about some of the basic design concepts so we can understand what we're doing here. And it will help you figure out how we're going to write the code. Now you can see the functionality here. I had a little bit of functionality since the first video, but basically we're just, when we start this up, we're going out looking for available COM ports down here. So we're going to have some code to look for the available COM ports. And then we're going to have the user specify what COM port, and you can you press the button to open the COM port, you can close it, and we're showing our real-time data coming from an Arduino. And in this case, we are measuring on the Arduino the frequency of the sine wave at the wall out that the voltage provided by the power company. We're measuring the frequency, and you can see it's right around 60 hertz. And we are also scrolling that data. We're scrolling the last 5 minutes of the data. We also can have the user can specify that data window. Here we've specified 5 minutes, and we're showing the last 5 minutes. The user can also set the y-axis, in this case frequency values, the maximum 60.2, you can see it's over here, 59.8, and technically you can change this in real time, though there are some issues with that. And I also allow the user to set the major and minor y-axis grids. You can see there's a major grid here at here's 60, 60.1. So I've got an interval of 0.1, and we talk about these grids in our series on C# charts. I encourage you to take a look at that. So you can change those values to change the major and minor grids. And then we can also save the data to CSV. So all of this data you see on this screen will be dumped to a CSV, and when we click this, it will append new samples into that file too. It'll keep the file open and keep appending as we get more data. And then we've got a debug checkbox, which is going to be very helpful when we're doing things in this application, find out it's not working, we can get some feedback. Very, very important, this debug. And here we're reading out the samples as they come in. So now one of the challenges we're going to have here, it may not be intuitively obvious at the outset, but we're going to have to figure out how we're going to deal with this X or time axis, all right? We got a bunch of choices, so we're going to have to decide how we want to do it. Now, one option is we can assign for each sample coming from the Arduino, we can assign a calendar date and time. If we are concerned about, for each sample, when did that come in, what's the day and what's the time. In my view, maybe we don't need that. If you think you need that, I've got a video on C# date time now, how that works. You can grab, when you get the sample, you can grab the calendar date and the time, and you can assign it to each sample. But for me, this is a real-time graph, and we know what the date and time is right now as we watch this, so we really don't need that information. To me, it's more important to say, okay, here's the last 5 minutes of data, or we can set it to 30 minutes or 60 minutes, whatever. But I know what the date and time is. I just want to know, the data over the last 5 or 10 or 30 or 60 minutes, right? So that's one choice. You can use date time now. Another thing is if you're really concerned about the accurate time between samples, on the Arduino, you can use a microsecond value between samples, and you can send that over the COM port to this computer. Again, that to me is a little bit of overkill because, generally you're going to be doing this in terms of minutes. So we don't really care about microseconds. So what we're going to do in this application is when we receive a sample, we are going to use a stopwatch, what's called a stopwatch in C#, and we'll talk about that. And we're going to restart the stopwatch, and that will give us a time between received samples. And we can use that as an increment to assign a new time value to each sample, okay? So that's how we're going to approach it. One other thing that we're going to need to figure out is, as you can see here, when I'm starting to, when I reach my limit of 5 minutes of a data window, I'm starting to scroll, and you can see this time, the time values stay fixed from 0 to 5 minutes. So up until 5 minutes, it's going to be adding to the time, but when we hit 5 minutes, this time value is going to be fixed, and it's only going to show the last 5 minutes. So we're going to have to think about how we're going to do that. You know, what we're doing is we're adding new values. We're showing the most recent value, and we're dropping off the value of that incoming signal 5 minutes ago. So each time we get a new one, we're dropping off the old one so we can get the scrolling window. And then the time values are staying fixed. Once we hit the window, we have a fixed set of time values. So we're going to have to scratch our heads and figure out how we're going to do that. So what I'm going to do is I'm going to approach it as I'm going to have two separate lists of data. One list is the sample values, in this case the 60 hertz wiggling values that come in from the Arduino. And the second list is the time values, all right? Because they're going to be different. And I'm going to have two separate lists, one for the time values, one for the sample values, so that we can operate on them independently. We're going to need that if we're going to chart this using this moving window of data. Here is kind of a written discussion of how we're going to approach this. To get the time values, we're going to calculate the time interval between received samples, right? So we're going to receive a sample from the Arduino and start a stopwatch. So when each sample is received, use the stopwatch to determine the interval between samples. So we receive a sample, we restart the stopwatch, it times out when we receive the next sample, and that gives us the interval. We're going to convert that to minutes because, as you can see, this is all going to be in minutes. You can use seconds if you want. I'm going to use minutes. And then for each sample received in your data received event handler, we're going to increment the sample's time value. So here it's going to be a time of 0. The next sample is going to be 0 plus whatever the increment minutes, and then we're going to add and add and add. And here the time value for this sample is going to be 30 minutes. So that's how we're going to handle the time values. We're going to have a separate list. And then for the scrolling window, we're going to say if the latest sample time value in minutes exceeds the window duration in minutes, then what we're going to do is we're going to take each value in the list of times and we're going to go through and zero those out. So we're going to start at 0 and increment the sample's time value using the interval in minutes and replace each time value in the list of time values with the incremented value. And then once we have that, once we've gone past this window, you can see the list of time values are going to stay fixed from 0, in this case, to 5 minutes. So that list of time values isn't going to change. Once we start going into this window, it's not going to change, so we can keep it fixed. And that's one reason why I'm going to have two lists, one list of sample data and then one list of time data. And we're going to have to remember those lists are going to have to be synchronized. In other words, the number of values in the sample list is going to have to be exactly the same as the number of values in the time list. So keep that in mind. That's going to be a very big issue. But that's how we're going to approach this. All right, we're going to have two lists of data, and we're going to have to make sure they're synchronized. Now, we talked about, we've got this filter functionality. We can, in real time, check that box, and we're going to see that this data coming in, we're going to get rid of a lot of this noise, and we're going to smooth this out depending on the settings of the filter. And it's going to filter from then on, it's going to filter the data, and we can uncheck it, and in real time, it's going to go back to the kind of noisy data. So that's the basic functionality we're going to address in the application. So let's jump into the C# code and see how we can do this. Okay, so here we are in our C# Windows Forms application. And it's fairly straightforward, very similar to what we did with the oscilloscope series where I showed you how to convert your Arduino into an oscilloscope. basically the same layout. We've got my main Windows form, and we got some using statements, my documents, to-do list, initializing, and I've got the main form 1, some methods, and some event handlers. I've also got a class, a separate class, and its main job is to grab the data coming in over the serial port from the Arduino, process it, and set up the data into 2 lists, one of all the time values and one of all the sample values. Those lists of data will be used in our main Form 1 application to actually do the plotting, okay? So this is just a processing and developing 2 lists that can be plotted. Very straightforward. And of course, the third part is my UI, and I've got a bunch of stuff here. I'm not going to go through in detail each one, but we've got basically 5 buttons. I've got an open port, a close port, a log button, which starts everything off, a stop, which ends the logging, and an exit button. So I've got 5 buttons, which means there's going to be 5 event handlers. And I've got a bunch of text boxes. I've got a text box here for the COM port, where the user selects the COM port. I've got a text box where the user enters the sample rate if I'm requesting data from the Arduino as opposed to just passively listening for data. I have to tell the application, the system timer, how often I want the system timer to send a request for data to the Arduino. So that's the user identified sample rate. Arduino VREF, that's the voltage that the Arduino is going to use with the analog to digital converter to convert the 0 to 1023 values into voltage. I did a video on that. Arduino data accuracy with USB, so I encourage you to look at that. And then data window, this is where the user specifies, for example, I want to see the last 5 minutes of data, and it will scroll. So we put in 5 minutes and it will scroll the last 5 minutes of data. I've got a Ymax and Ymin where the user can enter the maximum and minimum scales of the y-axis. I've got another text box where the user can specify the grids, the major and minor grids. We'll talk about that. I've got a scrolling text box that basically just gives us feedback. For example, it tells us what ports are available when we start up. And then I can use it to do debugging. If I want to look at some data, it can give us feedback on that. So that's all the text boxes. I've got here, I've got some radio buttons. If I want to put the sample rate in seconds or minutes, I can select those. Got some check boxes if I want to send a request or if I want to passively wait for data. If I need to convert to 5 volts, if the data is coming in 0 to 1023. If I want to filter the data, and some of these are real time where I can do it, like the filter data, in real time I can click this box and it will generate an event and that will suddenly turn on filtering. So I've got that checkbox and I've got the save to CSV. Again, this is a real time. It generates an event. If I click it, then I can suddenly start saving all my data to CSV. And I've got the debug checkbox. And of course I got my chart right here. And I've got a couple labels up here. I've got just the name of it, the logger. And there's another label up here that's invisible that's going to be showing us each sample coming in from the Arduino. It'll show us the value as it gets plotted. So I'm not going to go through all of these. You can set it up however you want, but this shows you there's going to be quite a few events for all the buttons and the real-time checkboxes and some other stuff. So there's going to be a lot of events, and there's going to be a lot of converting data from the text in this text box into values. All right. So that's that. You can set it up however you want. So now let's go back to the main Windows form and see how it's laid out. As you can see, I've got some using statements. System windows.forms, of course. System.management, I'm going to use for the COM port descriptions. Again, when I start it up, here is, after I just started up, down here I've got a list in this text box of which COM ports were found. And this system management library will go out and find the available COM ports. Very nice, and it will also give them a name that you can put here. You can say COM4 and COM3 are available, and then I can just select which one I want and open the port. Link, language integrated query, we're going to need some of that in parsing some of these COM ports. IO.ports, of course, and IO we're going to need for the COM ports. Collections.generic, of course, we're going to need that for the lists, because at the end of the day, this is all going to generate two lists for time and value. System Windows Forms, Data Visualization Charting, of course, we're going to be charting, and System Drawing. That's because we're going to be changing some colors inside the charts. So that's basically it with the using statements. You can pause the video and copy if you want that. Notice that I have a lot of regions here. For example, I've got my documents in a region. You just do pound region, end region to make some drop-down grouping of data and code so you can make it a little bit easier to look at. Here's my documentation. I've got a to-do list. I've got initializing, where I initialize some variables. I've got my form 1, and I've got some methods and event handlers. And again, there's going to be a lot of event handlers that are going to be working with all these UI components. So let's go through and look at the initializing first. I've only got a few variables here that we're going to set up. The first one is a public double, and I'm going to call it sample seconds. And that's where the user specifies if we're going to request data from the Arduino, we're going to send a request. This tells us how many seconds between requests, and we're going to use that to set up the logging rate. So we're going to need that. Major X interval, we're going to set the interval of the X-axis. We're going to default that to 0. Chart window minutes. Again, the user can enter how many minutes he wants for the scrolling window. We're going to default that to 1. Filter data, that's a Boolean. If we decide to filter the data up here, we're going to default that to false. Here I'm going to set up my serial port, public serial port, and I'm going to call it Arduino port. And my input data processor, which is this class over here that grabs the data and converts it into lists, we're going to call it processor. And the last thing is a path to the CSV file that we're going to either create or append new data to, and that's you can change that for however you want. So that's all the initializing variables we got. And then form 1 is going to be very straightforward. Windows Forms initialize component, that's the standard. And I'm adding two methods, one to set up the UI and one to set up the chart. Again, there's going to be a lot of UI and chart stuff. We got a lot of stuff going on here. So I got two methods to do that, but very simple form 1, and it's just going to call these methods. Now the methods, I've got 1, 2, 3, 4, 5 methods. The first one is that setup UI, and the next one is to set up the chart. And then I've got two more methods to go out and get the ports using that system.management, and it's going to return a list of the ports that are available, and then it's going to use that to enter into this text box. And then we're going to have the open port, which is going to get called by the open port button, and that's going to actually open the port. And then the last method is to save the data to CSV. And of course, if I click this, it's going to call this save to CSV. And if we look at the event handlers, as you can imagine, we've got a lot of event handlers. We know that 5 of those are going to be buttons. We saw the 5 buttons. We've got the open port, the close port, we've got the log button, and we have a event for the system timer. If we have to request data at a fixed interval, we've got the system timer that is going to send a request to the Arduino. So we got that event. And the big one is this data received event handler. Whenever we receive data, whether it's a requested data or just passively listening for data, it's going to come into this received event handler, and that's going to be doing all of the work. It's going to take the data that's coming into the port, process it, and chart it. So this is going to be very big. It's going to have a lot in it. I've also got 3 checkbox events, which is if we decide we're going to need to send a request as opposed to passively listening for data. If we're going to save CSV, which we can do in real time, that's why we've got this checked event. If I click this save at any time, it will automatically start saving the data. If we need to convert the data, if it's 0 to 1023s and we need to convert via the VREF to 5 volt values, we have this checkbox. And then, of course, the last two buttons are the button stop and the button exit buttons. So that's basically it. So let's go through and step through what this is going to do. And of course, we're going to be calling this Input Data Processor class, and we'll look at that in a bit. So Form 1, as we said, we set up the UI and set up the chart. So set up UI, public void setup UI, and as you can imagine, it's basically setting default values for a lot of these text boxes that we have on that form. Because when we start it up, you can see we've defaulted to COM3, so we're filling in COM3. Yours can be different. We're setting a Ymax and a Ymin for the Y-axis. The major grid interval and the minor grid interval, again, we talk about that in our C# charts videos. Take a look at that. And also the data window, we're defaulting to 30 minutes. So we're doing a lot of setting up of the text boxes. And we're also down here with the COM ports, we're filling out this data into the text box, which we're doing over here. We're appending the following active COM ports were found to the serial data. I called it text serial data. And then we're calling the get ports method, and it's returning a list of string, which is the list of ports. And then we're stepping through for each string S, which each port in the port list, we're appending to that same text box the S. So it's appending the ports. And this is the result. This is coming back from the system management. It says COM4 USB serial port COM4 and COM3 USB serial device COM3. So I've got certain buttons enabled but not yet visible because I'm just giving the user the option of which port to open, but I'm not making the log button, for example, visible because I have to open the port first, right? So I'm just doing a bunch of housekeeping to make sure that only the pertinent buttons are available to the user. So that's all we're doing with the setup UI. And then we go to setup chart. And as you can imagine, there's a lot of chart stuff. And we're going to be talking about in our charts video how to put all this into a class that does a lot of the work behind the scenes. But here what we're doing is we're just setting up, we're setting a series chart type line. We're setting the line width, which unfortunately is called border width, to 3. And we're setting up the color of the line to yellow. And then we're just setting up the x-axis and y-axis parameters. If you want to put this in, you can just pause the video and type it in. But we're setting up the minimum, the interval, which is this major X interval that we specified previously. We're saying round the access values. We're giving a title to the x-axis. We're choosing some colors. And then we're saying the line width of the grids. And then label color is aquamarine. And we're doing the same for the y-axis, setting up some colors. What we're doing here with the interval is we are grabbing what's in this major Y grid text box, and we're grabbing that as the interval, and we're setting the line color. And then the minor grid, we're setting that enabled, we're giving it a color, and we're doing the same for the minimum Y grid. We're grabbing this value and using that as the minimum Y grid, minor grid interval. And then we're setting a format and a color black, and we're clearing legends since we don't want legends. Again, you can pause the video and type that in, or you can just set it up however you want. So now what happens is the user selects the COM port from this and does an open port after setting all of these variables. So let's say we're going to leave these as default, and we're just going to passively listen for data. We want a 30-minute window. So we open the port, and now we are able to close the port, and now the log and stop buttons become visible. And we're all set to start grabbing data. Let's say we want to change this to 0.1 and this to 0.05. Now the other option is if we want to send a request, we can click on this and we'll automatically make this sample rate visible and also these radio buttons. So now we can say, well, I'm going to request every second or every 10 seconds I'm going to request data from the Arduino. If we don't want that, we can just uncheck that. Or we can say, I want to convert the data. The data is coming from the Arduino 0 to 1023. I want to convert that back to 5 volts using this Arduino VREF. And again, we did a video on that. But I'm not going to do that. I'm just going to passively wait for data. So I'm all set, and I can just hit the log button, and you can see it's starting to log. So once the user has figured out what he wants, he just hits the log button, and that starts everything going. So now let's look at the port methods. I won't go through too much detail. We already went through that with the oscilloscope application. But there's basically two methods here that work to get the ports for the user and then open the port. So again, I've got the get ports method, returns a list of the ports available. I won't go through this in detail. If you want to copy it, I'll just pause the video and copy it. Basically use the management object searcher, and we do some link here to grab data for the COM ports, and then it gets the COM port names such as COM4, puts it into a string array, and then here we go through some magic to develop a list of ports, and we return that ports list. So again, if you want, just pause the video and copy that. So when the user presses the open port button, it's going to go to this event handler, and basically all it does is it calls open port. So what does the open port method do? Well, we'll scroll down to this, and much of this is just enabling and disabling some buttons because now that the port is open, then we can start logging. But basically what it does is it says it assigns a new serial port, and we call it Arduino port. It sets the baud rate to 9600. Port name is COM plus whatever COM port the user specified. And then we try to do an Arduino port open. If you can't, we have a message box that says, dude, seriously, you need to like plug in the device first and then return. And while the port is not open, if it's taking time to open the port, it's going to put in that open port button some text that says, hey, I'm opening, hold on. Once the port is open, we're going to set these buttons as enabled and visible, and we're going to change some colors. Again, you can pause and just copy those in. So for example, we're going to say this is logging and the port is open, and we turn yellow and that kind of thing. So basically now we've got the port open, and what we're going to wait for is for the user to press to set up all the data, waiting for the user to set up all the data and press the log button to start everything going. So then we're going to go to the log button. So here's the button log click. And this is what happens when we click the log button. First of all, we need to grab the user input on how many minutes I want for the chart window. So we're just grabbing this value here, it's set at 30 minutes, and we're converting it to a double, and that's chart window minutes. We're instantiating a new input data processor class, which we'll talk about, and we're calling it processor. Then we're taking the log buttons. Once we've already pressed it, we want it to say that it's already logging, so you can't click it. And we're going to change the colors, so that's what that does. If we're going to convert, if the user has decided we need to convert the data, if that check.convert is true, processor.convert value, and that's over here in the input data processor, is true, and then the VREF is whatever the user has entered for the VREF in the text box, and we're going to set that as a value in this input data processor. And we'll go through that in a bit. And then if we need to send a request, if that checkbox is checked, then we're going to grab the sample rate that the user wants. So we're sending a request. We need to find out, okay, well, how often do I send the request? So we double.parse the sample rate value and call that sample seconds. And if it's minutes, if the red radio button minutes is checked, sample seconds equals sample seconds times 60. So it's just converting this to 60. And then the sample interval milliseconds is convert to int32 sample seconds times 1,000 because it's going to be in milliseconds. So again, you can just copy this stuff if you want. And then we're going to, since we're going to send a request, we're going to have to do it every fixed amount of time with the timer interval. So timer 1 enabled equals true, timer 1 interval equals processor sample interval milliseconds, right? So we're going to enable it, and the interval is going to be this sample interval milliseconds that we just calculated. And then we're going to write a line. If we need to send a request, we're going to send the first one now, but all subsequent requests are going to be from the system timer. So we're going to send our first request, and then we're going to discard whatever on the input buffer for the COM port in case there's junk. And then we're going to make the convert and send request checkboxes invisible. And then we're going to sign up for this data received event handler, because once we've sent a request, we need to be notified when the data comes on the port. So that's basically it for the button log click event. So now we have the timer 1 tick. So every time the timer 1 tick event occurs, if that checkbox for send request is checked, that means we're sending a request. That means every time we get the timer interval, we want to send a request. So it just says Arduino port.writeLine, the L, which means we're sending an L log request to the Arduino, and it has to respond. So very simple, the timer. Again, that's only if we're going to send a request. Otherwise, we don't need this timer. So the big thing right here is this data received event handler. And what it's going to do, I've got a region here for documentation. And what it's going to do is two things. It's going to process the input data. It's going to read the data from the port, and then it's going to plot the data. And of course, it's going to use this input data processor. So let's go through the input data processor and see what it does. Now, I've only got 3 using statements, using system, collections.generic. We're going to, of course, the big thing this thing is going to do is generate 2 lists. One, a list of times, and one, a list of samples. And then system diagnostics for a stopwatch. We said we're going to use a stopwatch to determine each time it receives data from the Arduino in the passive mode, it's going to find out what's the interval between the last stopwatch, and it's going to figure out for each sample what's the associated time. So properties, I've got a bunch of properties here, and mostly because we're going to have to get raw data string from the Arduino, then convert that to usable data. And if we're going to convert from 0 to 1023 to 5 volts, we got more conversion. So a lot of this stuff is just in the conversion process, we have interim values. We've got a Boolean, which is if the user chooses to convert the value from 0 to 1023 to 5 volts, that's a Boolean gets set. This scrolling window Boolean is if we have already exceeded, for example, I've got this set to 30 minutes. If our samples have exceeded 30 minutes and we're going to go into scroll mode, then that Boolean gets set after the 30 minutes. The one sample after 30 minutes, it goes into scroll window set mode. And then the input string, this is the raw data coming from the Arduino. It's basically the sample value, in this case, the frequency value. We're not sending any time values, just the frequency, and that's going to be the input string, but we're going to have to convert that. So it's a string that's going to have to be converted into an integer, and that converted into an integer is this input integer value. Then we're going to convert that to a double in some cases, which is the sample value. And then we're going to also have a sample value old. This is going to hold the previous sample value in case we want to filter the data. If we click filter to remove this noise, we're going to have a little algorithm in here that's going to use the present and the past sample values to kind of average them to get a filter. So we're going to need public double sample value old, and then time value is the present time value. We're going to use that to calculate time values for each sample we receive. And then these two, public list of double, are the very, very important data that this class is going to produce. The whole goal here is to produce two lists, one of time values and one of sample values. And we're going to use these two lists and send them to the plotter so they can be charted. This is the ultimate output of this input data processor class. Range double, this is for the analog to digital converter for the Arduino. It uses a 0 to 1023, so this range double is going to be a value of 1023, so we can convert back from an incoming 1023 to 5 volts. And then sample interval in milliseconds. The user is going to request data, and this is the interval in milliseconds. We're going to set the timer, system on timer. And then sample interval in minutes is going to be that converted to minutes. And then finally, we got the VREF, which is the Arduino VREF we talked about before. And then we've got a stopwatch that this data processor class is going to use to figure out the time between each received sample. So we got a lot of stuff in here. Again, pause the video and type it in if you want. But those are the basic properties. Now the constructor is going to, when we start this, we're going to have a constructor that sets some values. Time values is the list of time values that this thing is going to produce. And we're just setting that into a new list of double. Same with the sample values, new list of double. We're setting time value 0, sample value old, initializing to 0. We're going to default this to convert values as false, and sample interval in minutes is 0. So that's simple stuff for the constructor. And then we have only 3 methods in this input data processor class. The important one is we're going to call from this form 1, we're going to say, hey, I got some data in this string. I've got a string of data, and the user has said we want to filter that data. So we're feeding that as input from the form 1. Once the data received event handler gets the data, it's going to pass that string of input data and says, hey, here's the string, and we want to filter it or we don't want to filter it. And this is the main method that this input data processor class is going to use. So we're going to stop the stopwatch, and we will have restarted it down here. And we're going to figure out the minutes between this sample and the previous sample, and that sample interval in minutes. And it's basically taking the stopwatch elapsed time, which in total seconds, and dividing by 60. And that gives us, for each sample, a sample interval in minutes. All right. Now, since we're getting a string coming in, we're going to have to trim it. So string trimmed equals S, which is this string trim end. And we're removing the carriage return and line feed because we just want the raw string data so we can convert. Now, if we have said we want to convert that value from 1023 to 5 volts, we convert the trimmed value to an input integer, and that is our input integer value. And then we're going to call this scale value, and basically all that's going to do is take the 0 to 1023 in this input integer value, and using the VREF convert it to a scaled value, 0 to 5 volts, and we'll see that in a bit. If we don't want to convert the value, we're just getting raw data like our raw frequency. Our sample value is basically the trimmed value converted to a double. And here we're going to apply any error offsets. For example, if our hardware that we're getting connected to the Arduino measuring frequency, for example, is off, if it's got a fixed error, we can subtract that out here. And we showed in a previous video that I found with my measuring equipment, measuring frequency, was off by about 0.05 hertz. It was at 0.05 hertz high, so checking with a multimeter measuring frequency, I found that I've got this fudge factor in here. So this is the actual sample value after you account for the error. Now, if we're going to filter it, if the user wants to filter it, the sample value is a filtered version, and we're taking 20% of the new sample value, and 80% of the old sample value to come up with a new filtered value, which means we don't trust the new one very much, only 20%, and we're trusting the old one more. So that's how you filter the value. We get a new sample value, and then we're making the old value as the new value so that we can get a new sample value. And then the time value, we're incrementing the time value by the sample interval in minutes we talked about before to get a new time value. Now, if the scrolling window is set, if we want to have a scrolling window, we don't want to add to the time values list, all right? Only if it's not set yet. We haven't gone up to the 30 minutes here, for example. Then we're going to add to this time values list, only if we haven't reached the window. However, if we have, we don't want to add any more to the time value. We want to leave it fixed at the 0 to 30 minutes. So, but we are going to want to add to the sample values. We add this new sample that we just calculated to the sample values, and then we're going to restart the Arduino stopwatch, and then it's going to time out, and then we get the next value. We're going to be back here, and we're going to see what the elapsed time is. So processing the input, that's what we're going to do. We're basically determining, we just have raw data, or do we have to convert 0 to 1023? And then basically here we're just generating the time values and sample values list so that then we can send it back to the to get charted. Now the scale value, as I said, this is if we've received 0 to 1023 and want to convert it to 5 volts. The double, range double equals 1023. Sample double equals convert to double the input integer value. And then sample double equals vref over range double. So that's how you convert from the vref, say it's 5.2 over 1023 times the sample double, and that gives us the new sample value. So that's how you scale it. And then the scrolling window, basically what this is going to do is if we have exceeded the 30 minutes and we just want to maintain this at 0 to 30 minutes, we don't want to keep updating this list of time values. We want it to stay fixed at 0 to 30, and we want it to start at 0 and end at 30. So that's what this does. It sets the scrolling window at a fixed 0 to 30 value that we're not going to update anymore. So we're setting this tval initializing to 0 for int I equals 0 to time values dot count. We're going through to each time value in the list, and we're setting it from, we're starting out with tval of 0, and then we're incrementing it by the sample interval in minutes. So at the end of this, we should get 0 to 30 as the time values in this list. So that's basically setting the scrolling window so that we have a fixed 0 to 30 in the time values. And that's about it for the input data processor class. So now let's look at the most important part of this whole thing, which is the data received event handler. And this is going to happen whether we requested data or we have just passively waited for data. It's all going to come down to this event handler. And I've got 3 regions here. I've got my documentation, I've got the process input data, and then the plot data. Process input data is going to send the input data. It's going to grab the input data, send it to the input data processor, and at the end we've got the 2 lists, and then it's going to plot the data from those 2 lists. All right. So how does it process the input data? Well, first thing, it's got to read the data from the serial port. Serial port, I'm going to call it SP, is a serial port sender, and the input data is sp.readline. So this is the string coming from the serial port. If the user wants the data to be filtered, if the check filter.checked is true, and keep in mind, this is every time we receive data, so this is real-time determination of whether we should apply filtering. So if check filter checked equals true, then filter data equals true, else filter data equals false. Very easy. And then we're going to call the process input that we just went through in the input data processor, process input, and we're going to feed it the input data and the Boolean whether we want to filter the data. All right. So if processor.timeValue is greater than chart window minutes, this is going to set up the scrolling of the window. So if the time value of the latest sample is greater than the 30 minutes or whatever, then we're going to set up the scrolling window. If the scrolling window set is false, we haven't yet started scrolling the window, the processor.setScrollingWindow is going to be called to do the scrolling, all right? And then we're going to set that scrolling window set equals true since we just set it. And then what we're going to do is, since we're scrolling, we have to remove the earliest value of the sample values array so that it will scroll. So we're removing the value at 0 in the list. Very important that we remove the oldest value so we can add a new value and it will scroll. So here we have basically processed and sent the data to this input data processor class. Now we need to go through and chart it. So here is the region for plotting data. And there's a bunch of stuff here. Don't get afraid. It's basically what we're going to do is we're going to put the chart on a separate thread. And we talked about this before. Chart 1, invoke, new method invoker, and delegate. And we're going to chart the data. Now, what we need to do, if we're going to chart, we need to figure out the Ymax and Ymin values in these text boxes. So the user said, I want this to go from 60.2 to 59.8. So what we're going to do is we're going to read those values, convert it to double. If the processor.sample value, this is in case the new value is outside that range, it will automatically update these maximum values, or if it's below that range, it will automatically update the minimum. So I've got a function here that will automatically update the maximum and minimum if we go outside the range. You don't need this if you don't want it, but if processor.sample value, if the latest sample value is greater than what we've specified for maximum, then change that maximum text to show the new sample value. And same with the minimum, all right? Now, this is used so that we can figure out the minimum and maximum values and apply that to the chart for the y-axis, and also the interval and the minor grid interval, all right? So that's basically these 4 checkboxes. We want to make sure that we grab the data that the user has entered into these checkboxes and apply it to the chart. And we can kind of do it in real time. I can change this to 60.3 and it will automatically update. Be careful though with this, it's kind of dodgy. If you do it too slow, it's going to crash your program. So I'm doing kind of a very simplified thing here, but if you really want it to be real time, respond to user requests, you're going to have to put in some code to clean this up. But this basically takes the Y minimum, Y maximum, Y grid interval, and minor grid interval and converts those into values for our chart, all right? Now, if we have decided that we've exceeded that interval and we're starting to scroll the window, if processor.scrollingWindow set equals true, then what we want to do is chart area 1, axis X, we're going to set the minimum to 0 and the maximum to whatever that, like 30 minutes, all right? So it's going to be a fixed value. If we're scrolling, this is where we set the fixed value of 0 and 30 minutes, all right? Now, while the processor time values.count is greater than the processor sample values.count, remove a value from the time values. This isn't really needed. I just wanted to show that when we chart this, we're going to use a data bind XY, which basically takes 2 lists and charts one list as the X value and one list as the Y value, which we're going to have for the time values and the sample values. However, if those 2 lists don't have exactly the same number of elements, this is going to crash. So, and that's one reason why you probably want to debug in here. What I've done with this debug is I click the debug and it tells me the number of elements in the X value and the Y value, or the time values and the sample values. It gives me a real-time update. So you can see if there's any problems. If these don't match in count, this thing is going to crash. So this basically says, if they're not matching, then go through and remove some of the time values. But again, this is just kind of a notice that, hey, you've got to make sure that you're checking to make sure that both lists are same length. And then once we've got that, if the processor.timeValuesCount equals the sample values count, no problem with the number of elements, they're both the same number, then we can chart the two lists. And I'm using a points.databindXY, we'll talk about in our chart series, processor.timeValues and processor.sampleValues, all right? If that doesn't match, I'm going to have a message box, dude, the time values and sample values lists need to be the same length. Okay, so that's basically doing the charting. Now, the debug checkbox, if it's checked, I'm doing another thread for the serial data checkbox or text box. And you can just copy that if you want, or not use it if you don't want. It just says, here's the time values.count and sample values.count. This is basically to put this data, the received values, into a label. So label data.text is processor sample value with an F2 format. And then if I want to append, if I have checked this, saved to CSV, and I want it to append subsequent values, if check save.csv is checked, then this is going to use Streamwriter SW file append text, and we're going to use that log file name, and it's going to append subsequent new samples to the already existing CSV file. And we're just going to use a right line processor.timeValue to string plus comma plus processor sample value to string. And that's basically going to do our CSV file. And that's it for the data received event handler. So finally, I've got 5 more event handlers. I'll go through real quick since probably there's nobody watching now. Anyway, send request, check change. You can copy that if you want to. Just pause the video, save CSV. If it's checked, I go to the save list to CSV method. Otherwise, I set the save location to empty. Convert. I'm just making text box and labels invisible. Button stop. I'm unsubscribing from the event handler and doing some cleanup. And then if the save CSV is checked, I save the list to CSV, which we talked about. And then the final one is button exit. This basically closes the port and does an application exit. So that's about it. I think I've covered everything for the logger application. If you like any of these videos, I appreciate if you hit the like button, subscribe, hit the bell notifications, and most of all, let others know that we're here so we get some more viewers. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.